Europa, one of Jupiter's largest moons, has intrigued scientists for decades. Beneath its icy surface lies one of the most promising places in the solar system to search for life beyond Earth. But what do we actually know about this mysterious world? Today, we'll dive deep into everything we know about Europa, from its icy shell to the ocean hidden beneath. Join me as we explore Europa's surface, its subsurface ocean, and the exciting possibilities it holds for future exploration. Europa is one of the four Galilean moons, discovered by Galileo Galilei in 1610. It's the sixth closest moon to Jupiter, orbiting the gas giant at a distance of about 670,000 kilometers, or 417,000 miles. Europa is roughly the size of Earth's moon, with a diameter of about 3,100 kilometers, or 1,900 miles. Though similar in size, Europa is very different from our moon. Its surface is covered in ice, and it has an extremely thin atmosphere composed mostly of oxygen. But the most exciting feature of Europa is what lies beneath its frozen surface. Europa's surface is like a frozen landscape of mystery. It's covered in a thick layer of ice, ranging from 10 to 30 kilometers deep, with countless cracks and ridges that crisscross the moon. These cracks are caused by the tidal forces exerted by Jupiter as it pulls and stretches Europa's surface. This tidal heating causes Europa's ice to crack and shift, but it also creates friction, generating heat beneath the surface. This is a key reason why scientists believe Europa has a liquid ocean beneath its frozen shell. One of the most exciting discoveries about Europa is that beneath its icy crust lies a vast, salty ocean. This ocean may contain more water than all of Earth's oceans combined, up to 100 kilometers, or 62 miles, deep. This ocean is kept warm by the same tidal forces that crack the ice, which could potentially make Europa one of the most habitable places for life in the solar system. Although Europa's ocean is trapped beneath kilometers of ice, it's possible that chemical reactions between the water and the moon's rocky core could create an environment similar to Earth's deep-sea hydrothermal vents, where life thrives. Europa's ocean has all the key ingredients for life as we know it: water, heat, and a potential source of energy from the interaction between the ocean and the moon's core. This has led scientists to consider Europa as one of the top candidates for finding extraterrestrial life within our own solar system. While we haven't yet detected life on Europa, the possibility that its ocean could harbor microbial organisms is a major motivation for future missions to explore this icy moon. Europa has been visited by a number of spacecraft, starting with the Pioneer missions in the 1970s, followed by Voyager and then Galileo, which provided our first detailed images of the moon. But the most exciting missions are yet to come. NASA's Europa Clipper, set to launch in the mid-2020s, will be the most ambitious mission yet. The spacecraft will perform dozens of flybys, mapping Europa's surface in unprecedented detail and searching for signs of subsurface activity, like plumes of water vapor that may be escaping from the ocean below. Scientists also hope to one day land on Europa's surface, drill through its ice, and directly sample its ocean. This mission could bring us closer to answering the ultimate question: are we alone in the universe? Europa's surface is one of the most visually striking in the solar system. It's marked by features known as lineae, long, dark lines that stretch across the moon's icy shell, some extending for thousands of kilometers. These are believed to be caused by cracks in the ice opening up and refreezing. Another interesting feature is the so-called chaos terrain, regions where the ice appears to have broken apart and refrozen in disorganized patterns. These areas could be evidence of ice moving over liquid water beneath the surface. Europa has an extremely thin atmosphere, composed mostly of oxygen. Unlike Earth, this oxygen isn't produced by life, but by a process known as radiolysis. Jupiter's powerful magnetic field bombards Europa's surface with radiation, splitting water molecules into hydrogen and oxygen. The hydrogen escapes into space, while the oxygen remains. While Europa's atmosphere is too thin to support human life, Understanding its composition is important for future exploration missions. Europa's interaction with Jupiter is critical to its geological activity. The Moon is locked in a gravitational tug-of-war with Jupiter and its neighboring moons, Io, Ganymede, and Callisto. This creates tidal forces that not only heat Europa's interior, but also keep its ocean in a liquid state. This constant stretching and pulling may also drive chemical reactions at the ocean floor, providing a potential energy source for life. The future of Europa exploration is incredibly exciting. With missions like Europa Clipper on the horizon, we'll soon get a closer look at what lies beneath Europa's icy crust. The search for life on this distant moon could unlock answers to some of humanity's biggest questions. Will we find life in Europa's hidden ocean? Only time and science will tell. Europa may be one of the coldest places in the solar system, but it's also one of the hottest contenders in the search for extraterrestrial life. Its icy surface, hidden ocean, and interaction with Jupiter make it a world unlike any other. As we continue to explore, who knows what discoveries await? If you enjoyed this deep dive into Europa, hit that subscribe button for more videos about the wonders of our solar system. What do you think we'll find beneath Europa's ice? Let me know in the comments below.